Hello everyone, this video covers problems 6 to 10 from Think Through Geometry. If you haven't purchased the book yet, I've included the URL in the description of this YouTube video. Problem number 6. What is the length of a point, if any? Draw a dot, call it A. Of course, there's no length associated to this particular point, so if we were to say there's a length, then we gotta say 0. So we can usually call the length of a dot would be 0. Number 7. If x, y, and z are collinear in the written order, so they stay on the same line. Let's draw the picture. X, y, and z. Okay. So there's going to be the length xy. So we have the segment xy. Now, xy represents the length of segment xy. Now, this is written as 3x minus 2. And we get yz, which represents the length of a segment, yz. So I'm going to write it down. Length of yz. This happens to be 5 minus 3x. And according to the rule, because they are staying on the same line, or I would say x, y, and z are collinear, then we can tell by the something called segment addition postulate, segment addition postulate, we can actually say that xz equals xy plus yz. Now, if you just add it up using the substitution, you can tell that 3x minus 2 plus 5 minus 3x, we can tell that the answer for this given problem, if you cross it out, we end up getting 3. So here's the answer for number 7. And problem number 8, given two distinct points A and B, draw A and B. There exists a midpoint M. Normally, midpoint is unique. It should stay on the same line as AB, and it should also stay in the very middle of those two points. So we call this M. Now, AM is supposed to be 3. This indicates that we have BM equals 3. Now we need to find out the length or the value of AB. The length of AB would be AM plus BM, which is going to be 3 plus 3. The answer becomes 6, according to the segment addition postulate. Now, problem number 9. Given 3 different points, A, B, and C, where AB and BC are 4 and 5 respectively, and A, B, and C are collinear, then the sum of all possible values of AC equals. Okay, so we can get actually 2 pictures, AB and C out there, which is going to be 4 and 5. This particular picture or a diagram shows that AC would be 9. But at the same time, we can also have CAB, because nobody said that AB and C are collinear in the written order. So you can tell that these are 1 and 4, but still it makes sense. BC becomes 5, AC equals 1. So I would say the answer becomes 1 for the second diagram. Now we need to find out the summations of all these possible values of AC. So the answer becomes 9 and 1, hence 10. Now last problem. Given 3 distinct points U, V, and L, there's UV, I'm not sure about those points, I would say, but we have 2x minus 3. And at the same time, there's going to be VL. Nobody said that these UVL are supposed to be collinear, so we can actually draw a point somewhere else. So VL, it becomes 5 minus 6 times x. And it says UV and VL cannot happen. They cannot be the same thing because the length of any segment must be greater than, well, let's just try to figure out. 2x minus 3. What happens if they are equal? 5 minus 6 times x. And we get 8x equals 8, and x equals 1. So we think that we found the valid values. But if you plug it in, we can actually we can find out an interesting thing. We get -1, And at the same time, 5 minus 6 times 1, which is becoming negative 1, we get VL and UV having a negative length, which makes no sense. So I would say the length of any segment must be greater than 0.